All right, so good morning, good afternoon, or good evening. This is Dr. Franklin, Assistant Professor at Norfolk State University, bringing you another tutorial for statistics. In particular, this tutorial is dealing with the manual calculation of a two-sample t-test. So we'll actually work an example out of the statistics textbook that's being used for my course currently, so that you'll be able to apply it to some examples that you may be completing in class or for homework. Okay, so this is for a two-sample t-test. And before we get started with the actual example that we'll be completing today, let's go ahead and just list out the different formulas, raw score formulas, that is, that you'll need to eventually solve your problems, because most of your problems are phrased within the context of expressing or saying that there is a significant difference between two different groups. Okay, so these are the formulas that you will need. So there's this symbol, which stands for pooled variance. And it's oftentimes the first statistic that I tell individuals to calculate en route to calculating your two-sample t-test. So this is the symbol for pooled variance, lowercase s, lowercase p with a superscript of 2. And the formula for that is sum of squares 1 plus sum of squares 2 over degree of freedom 1 plus degree of freedom 2. Okay, if you're in my class right now, you should be familiar with what these symbols mean. You should be able to look at them and instinctively know that when you see two capitalized S's, it means sums of squares or sum of square deviation scores. These subscripts that you see here basically identify particular samples. So in this case, it would be the sum of squares for sample 1, and this would be sum of squares for sample 2. DF, so these are really abbreviations, but I'll say symbols that stand for degree of freedom, and there's a subscript of 1 and there's a subscript of 2, which means that this is the degree of freedom for group 1 and this is the degree of freedom for group 2. So you'll need to calculate your pooled variance. You'll also need to calculate your estimated standard error. And this is what the raw score formula looks like. Okay, so this is what the raw score looks like for the estimated standard error. All right, so I'm not getting into a whole lot of conceptual information about what these actually mean, or definitional information as it pertains to these two different types of statistics. I'm just focusing on the manual calculation here. Inside of the raw score formula, you see pooled variance listed here, pooled variance listed here as well. So you'll actually have two instances of the same score within this raw score formula. There's an N, which stands for sample size, with a subscript of 2, which indeed shouldn't be 2, it should be 1. Let me change that. So that should be lowercase n with a subscript of 1, lowercase n with a subscript of 2. Okay, so what this means is that this is the sample size for group 1, and this is the sample size for group 2. Okay. And then lastly, there's the two-sample T statistic. It's a minus there. Okay, so this is an entire symbol or an abbreviation within itself, meaning that this represents the estimated standard error, and it's not listed here as an algebraic equation. So you won't be plugging M1 and M2 in here, but rather all of this represents this raw score formula right here. Okay. So in the numerator you have sample mean 1, and sample mean 2 is being subtracted from it, and it's going to be divided by the estimated standard error. Okay. So with the problems that you'll be working in class, you will typically move through these statistical formulas in this order. So you'll most likely start with calculating the pooled variance, then afterwards you'll calculate the estimated standard error, and then finally you'll calculate your two-sample t-test. Okay, so let's go ahead and work an example. All right, so this particular example is going to come from page 310 in your Gravetter and Wallnau statistics textbook. So page 310, and we're going to just do 16A. So page 310, 16A. So if you have your textbook, you can feel free to go ahead and open it up and follow along. And again, this is by Gravetter and Wallnau, Essentials of Statistics for the Behavioral Sciences, and it's the 8th edition. Okay, so depending on whatever edition you have, if it is indeed not the 8th one, you may flip to that page in that particular example and find that it's not the one that I'm working. So this is as it relates to the 8th edition of that statistics textbook, the required text right now for the course. That may change moving forward. Anyway, in the particular example that's given, there are some details about the sample that are offered to us. So I'll write those out, and then I'll give you the back story on them. Okay, so this particular problem is all about the investigation of how negative experiences affect your well-being in the long run. Okay, so it's all about how negative experiences affect your well-being in the long run. Is it detrimental to you? Does it cause you to have a reduced sense of wholeness and mental, physical, and emotional wellness? Or is it beneficial to you in that you're able to move forward in a rather adaptive way in which you can find a lot of meaning from those negative experiences and thus move forward with your life in a positive way? So there's two different samples that are described to us. There's one sample which consisted of individuals who had two or few negative experiences, had 18 participants in that sample. The mean for that sample was 42, and this is their wellness score. So I think that it's safe to assume that as the wellness score increases, it would probably mean an increased sense of well-being or overall wholeness. Okay, so their average was 42 for these 18 participants with a sum of squares of 398. Now, there's also another sample of individuals who experienced about 5 to 10 negative experiences with 16 participants with a mean of 48.6, which is a little bit higher than the folks that really haven't had as many negative experiences. And their sum of squares was 370. All right. The problem is asking us if there's a significant difference in terms of wellness and whole being between these two groups. And that's what we're going to investigate with this problem. Okay, so we're going to use the two-sample t-test to do that. It also goes on to give us some information about the type of test we should use. So they said that it should be two-tailed. There should be an alpha level of 0.05, and then of course you'll need to know your degree of freedom. Okay, so it's two-tailed because apparently the researcher is not sure where the difference is going to exist. In other words, will it be the case that the individuals with two or few negative experiences have significantly more ratings of wellness than this group, or will the inverse be the case? So the researcher isn't sure, so they're just open to differences that may occur, and thus it's a two-tailed test. Okay, there's an alpha level of 0.05, which is the amount of error that's built into the study. So we'll be looking in, since it's two-tailed, we'll be looking in the upper and lower 2.5% of the tails to see if there are significant differences. And then our degree of freedom. We need that in order to find our T-critical in the back of the book. And this is the formula for our degree of freedom. Okay. So because we're working with two samples, we'll be getting the degree of freedom for each sample respectively, and then we'll add those up to come up with our total degree of freedom, which we'll use in the back of the book. Okay. But before we do that, let's go ahead and identify these two samples as either being sample 1 or sample 2. Okay, because if we come over here and look at our formulas, we see that these sums of squares are demarcated by either 1 or subscript of 2. The same thing in our formula for the estimated standard error. We see a sample size that's designated as sample size for 1 and sample size for 2. So we need to go ahead and identify which one will be which and be consistent with our identification of elements in these particular samples to make sure that there's no confusion there when we're doing our calculations. So I usually designate the sample as being the first sample, or sample number 1, based on the means. So if this group has the highest mean, I'll go ahead and designate this as sample 1. But in truth and actuality, it does not matter which one you designate as 1 and 2. It will determine how you go about interpreting the significant difference, though. So that's really important. So I'm giving you an approach that says go with the highest mean and designate everything as it pertains to that sample mean as 1, but there's no set way that you need to do this. You can very well designate this as sample 1 and you'll still come up with the same answer. Okay, so we're going to designate this particular sample as sample 1 by adding a 1 subscript to each of these characteristics as it pertains to the sample. And if this is 1, we're going to go ahead and designate this as 2. Okay, and again, I designated all these elements as sample 1 just because that mean was higher, and I find that it aids a lot of new students in their interpretation of the particular test if there is a significant difference. Okay, so we need our degree of freedom. So N1 minus 1. Okay, so we plug that in, 16 minus 1 plus N2 minus 1. So N2, which is 18, minus 1. So if we do that math, you should get a whopping 32. Okay, and we just followed our order of operations as it pertained to this formula. 16 minus 1 is 15, 18 minus 1 is 17. So we took care of parentheses first, then we added them up to get 32. Okay, so 32 is our degree of freedom. Now, if you go back to your t-distribution table to find your t-critical score, using these particular pieces of information, what you'll find is that your t-critical is plus or minus 2.042. Okay, so that is your t-critical. That is the standard in terms of accepting or rejecting the null hypothesis. And the null hypothesis says that there is no significant difference between these two groups. In other words, their wellness scores for the most part are the same, and negative experiences really do not have an impact whatsoever. Okay, so 2.042 is the boundary marker over here, and it's the boundary marker below. Okay, so if our t calculated exceeds 2.042, or if our t calculated is lower than negative 2.042, meaning that it's something like 2.043, which means that it's lower, right? So it's a little counterintuitive. That means that we would reject the null hypothesis and accept the research hypothesis. Okay, and just for the sake of time, we're not going to write those out. So let's go ahead and work the statistic, first starting with calculating our pooled variance. Right, that's what you really came here for, so let's hop into doing that. So we're calculating our pooled variance, and this is the formula for it. And I'll just rewrite it again, because repetition as it pertains to statistics is a great thing. It will really help you to be able to remember these concepts. So sum of squares for sample 1 is 370, right? So let's pull that 370 down, plus sum of squares for sample 2 is 398. So we'll throw that in there, over our degree of freedom for sample 1. All right, remember we did that right here, and 1 minus 1 and 1 minus 1, so that would be 15, plus our degree of freedom for sample 2, which is 18 minus 1, which gives us 17. Okay, now we're just going to follow our order of operations to get this pooled variance. So 370 plus 398 gives us 768, and 17 plus 15 gives us 32. Okay. Now, 768 divided by 32 gives us a pooled variance of 24. Okay, so that's our pooled variance. Next, we'll calculate our estimated standard error. And this is the formula for that. Okay, so let's go ahead and plug everything in. 24 plus 24, and our sample size for N1 is 16, right? 16, and our sample size for N2 is 18. All right, so just quick note about the estimated standard error formula. unlike your pooled variance formula, these fractions are separate. Okay, so there's not just one whole fraction like you see in your pooled variance, but rather down here, your estimated standard error, there's a fraction right here, then it's plus another fraction. Okay, so why am I saying this? Because it's important, because if you approach it like you did the pooled variance, you won't get the same answer possibly. Your order of operations will go in another direction. So it's important for you to pay really particular attention to the formulas and make sure that you follow them to a T. Okay, so 24 divided by 16 gives us 1.5, and 24 divided by 18 gives us 1.3. And don't forget your square root. So everything that you don't do, make sure you drag it over, because it can be really easy to forget to do a particular algebraic expression in an entire raw score formula. Okay, if you don't just carry it forward. 1.5 plus 1.3 gives us 2.8. I'm just bringing things down. And then lastly, you need to take the square root of 2.8 and you will get 1.67. And that is your estimated standard error. All right. And then lastly, what you'll do is the two-sample t-test. All right. So that formula is M1 minus M2 over estimated standard error. All right. So M1 was 48.6 minus M2, which was 42, over what we just calculated, 1.67. So that's your estimated standard error. So if we subtract 42 from 48.6, we will get 6.6. That's over 1.67. Okay, so what did I do? I just took 42 from 48.6. That's how I got 6.6. And I dragged that 1.67 over, which I got from the previous step, that estimated standard error. So 6.6 divided by 1.67 will give you 3.95. And it's a positive 3.95. Okay, so this is your final answer in terms of your calculated two-sample T. Positive 3.95. Now, those are all the calculations as it pertains to a two-sample t-test. Now, in terms of figuring out if the null hypothesis is true or false, you have to compare. In order to do that, you have to compare your calculated T to your T critical. Now, 3.95 is greater than a positive 2.042, right? If we were to go to our curve here and zeros in the middle, we would find that 3.95, and it's a positive score, so it's on this end, 3.95 would probably be somewhere out here. So it's in the region of rejection. Okay, the region of rejection, the region of rejecting the null hypothesis and saying indeed that the research hypothesis is true. Okay, so in this case, you would reject null, and if you reject the null, that means you would accept the research hypothesis. Okay. So what does this ultimately mean in terms of answering the question? It means that there is a significant difference between folks that experience 2 or few negative experiences, and folks that experience 5 to 10 negative experiences. How so? Well, based on our data, based on what we just calculated, it seems to be that the folks that experience more negative experiences have a greater sense of wellness and wholeness, perhaps because they're able to glean positive things from these negative experiences and use them in helpful ways moving forward. Okay, because ultimately this sample mean was greater than that sample mean. All right. This is the approach that I use for helping you calculate the 2 sample t-test. It is not the only approach. You may have to vary your approach based on the elements that are given to you in your particular worded problems. But for the most part, this is what you'll use to go about completing the examples in your textbook and in my assigned examples. Let me know if this was helpful with a comment or pass it on to a friend, and I wish you much success with completing all of your statistics related problems. Take care.